In this project, I use Azure to configure a cloud-based machine learning production to model, deploy, and consume it. So for that, we go to the Azure portal, we look for Microsoft Azure Machine Learning, and then we launch the studio. When we launch the studio, we'll see this page, and the first thing that we need to look is if the data is available. So we need to upload the data set to Azure Machine Learning Studio so that it can be used when we want to train the model. So I've already uploaded that data, and we can see this data is available, and we can click on it, review it, see how many columns are there, and just get some basic statistics from the data. Okay, now that we have our data uploaded, we can create a new automated ML run. We go here, and then we click on new automated ML run. We choose our data set. We just check that there's a preview of the data, and then we can click close, next. We're going to give the experiment a name. So I would call it AutoML experiment, and then choose a target column, and then choose a cluster. If not, we'll create a new cluster. For that, I'll choose a DS 12v2. So we configure a new compute cluster for the virtual machine, and we click next. We give the compute cluster a name. I choose the number of the nodes to be 0, so whenever the machine is idle, so it doesn't actually work, and then I select the maximum to be 5. Then I click here, create. Okay, after the cluster has been created, so we click next. The task is classification. We click on view additional configuration. So I choose my primary metric is accuracy. The exit criteria, I'm going to save and change it to 1. The validation, it's auto, and the maximum concurrent iteration I'm going to set as 5. And I'll save. So we are all set, finish, and we'll let the AutoML run to be created. Okay, here the AutoML has been created and the experiment is running. We can click on the experiment and we can go to our experiment, AutoML experiment, and we can see the status is running. It usually takes, like, for this particular problem, around 25-30 minutes, and we'll come back when it's completed. So our experiment actually has been completed. We click on it and we can see that it took like around 21 minutes. To check the best model, we can see the voting on Zemba with the accuracy of 92% is our best model. And so we can go to the models and check that one. And since this is actually our best model, we can go ahead and deploy it. We'll give a name to our deployment. I'm choosing ACI as our compute, and then also compute type, and I'm going to enable authentication. And then I click deploy. We'll come back when the deployment has been finished. Okay, the model is successfully deployed, and we can access the model endpoint in the endpoints. We click here. We go to our deployment, and we can see the deployment state is healthy, meaning that our model has been completely deployed. Okay, once we've deployed the model, we need to monitor the model's performance, which we can do using Microsoft Azure's Application Insight, which is an application performance management, an APM service, which is available as a feature to monitor. So now that we've deployed the model, we can go ahead and enable the Application Insight and retrieve logs. So the way that we do is we have the logs pie, we click on it and make sure that we use the same deployment name that we've already used in the portal. And then we go here and then we save it, we say Python logs, and we run it. And so we basically enable the application inside here. So once the spin finish, if we go to the best AutoML best deploy model, we can see that still transitioning, but once the transition is finished, the application inside, you can see it's enabled, and we have the URL that we can use for documentation. Okay, this step will consume the deployed model using Swagger. Azure provides a Swagger JSON file for deployed models, so we can go here. copy this, paste it, and we can see the Swagger JSON is appearing here. We can right click and save it in the same folder that the Swagger is actually there. Where in this folder we have swagger.sh, the .py scripts basically. So if I go here to my Swagger and if I open the swagger.sh, we can see we have different ports. The 8080 port is actually an internal port, which we're not going to change. It is a internal port of the Swagger UI Docker container. We're not going to modify it, but we're going to modify the 80. Initially, my port was chosen like 80, but I don't have a permission for port 80 in this computer, and so I've changed it to the higher one, which is 9000. If I open the serve.py here, we can see that the port that I choose is 8000. We have to make sure this is different from what we are choosing the Swagger .sh. Okay, now we are going to run a Docker. So we go to the Swagger folder. We make sure that we have the JSON file in the same folder that the .py and swagger.sh is. And we open the terminal, and then we going to write bash swagger.sh, and this will run the swagger.sh. Okay. Now, what we do here is we go to the localhost 9000, which is the same port that we chose for swagger.sh. And when we click here, we can see that the Swagger Pet Store is coming, which is another project. So what we do is we go to the same folder that the Swagger it is, and then we make sure, as I said before, that the serve.py port is been chosen for 8000. And then we're going to run the serve.py, and so here we make sure it's 8000. We open a bash, and we go into the same folder, and we say, okay, run serve.py. Once this is over, we can come back and go to the local host with 8000 and check our Swagger JSON. Okay, we can now consume the model endpoints. We are now in the endpoints. Click consume. We have the REST endpoint URL and the key. So we open the endpoint.py in our folder, and we replace the REST endpoint and the URL here, and then we save it. And then we can go to the same folder, and then where the endpoint is, and say Python endpoint. And when we click here, we can see the results here. Okay, now we have click here, Python serve.py, and then if you go to the Swagger and then put this information, which is the same port that we use for the for swagger.sh, and we click explore, we will see our project. If we go to the post, we can see the detail of our Swagger, and this is actually running. Okay, we can now consume the model endpoints. We are now in the endpoints. Click consume. We have the REST endpoint URL and the key. So we open the endpoint.py in our folder, and we replace the REST endpoint and the URL here, and then we save it. And then we can go to the same folder, and then where the endpoint is, and say Python endpoint. And when we click here, we can see the results here. Okay, for this part of the project, I'll use a Jupyter notebook provided in the starter file, and I'm going to update this. Just a quick walk through this Jupyter notebook is we're going to call the libraries, and then we're going to define our workspace from the configuration I've already used and added in my folder. I'm going to name the experiment M1 experiment, make sure that I use cluster, if not create a new cluster, and then calling my data set and review the data, and then create some configuration for creating the pipeline. The task is classification and choosing the ground truth, and then setting up the AutoML with the configuration that we chose, and then we start the running. As soon as we started running, we can go to the Azure portal and we can go to the experiment and check this experiment. This also had been taken like around 39 minutes to complete it. And we can get more information by going through the runs and the steps to learn how this has been going on and check the runs.